This video is about inequalities in one triangle, and what we're going to try to figure out here is how we can apply inequalities into problem-solving situations, especially in triangles, where we're going to be able to organize angles and sides differently. So the first thing we want to talk about is this idea of something called the comparison property of inequality. And what it says simply is it says if some value A is equal to the sum of two other values, if A is equal to B plus C, then we can conclude that A is greater than B, or we can conclude that A is greater than C. If two things added together, and assuming that C is positive, if two things adding together add up to this thing that we're calling A, then A has to be greater than either of those pieces. I put the proof on here just in case anybody was interested to see how you would do that proof, okay? But what we really want to see is how it applies to something we already know. So we already know this thing that's called the triangle exterior angle theorem. And it says that the exterior angle of a triangle is equal to the sum of its remote interior angles. In other words, we know from this that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Secondly, we know in this, because we're dealing with angles in or around a triangle, we know that they always have to have a positive measure. What we're able to conclude because of the comparison property of inequality is we're able to conclude that angle 1, the exterior angle, has to be bigger than angle 2, and it also has to be bigger than angle 3. Okay, again, here's a proof if you are interested on how to prove it. They did this as a paragraph proof. So let's take a look at a situation and now try to solve it. Okay, so I look at this image right here and they want me to determine why is the measure of angle 2 greater than the measure of angle 3. Because of this word why, I know what I have to do is demonstrate my thinking process almost in the form of a proof, but I don't have to make it formal in the sense of statements and reasons. The first thing I notice is I am dealing with an isosceles triangle BCD. All right, and that isosceles triangle tells me by the isosceles triangle theorem that I know that the measure of angle 1 must equal the measure of angle 2. The reason why I chose that is if you notice, there's now that angle 2 part of what they want me to figure out. I also know angle 1 is an exterior angle of triangle ABD. So I know that the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. There's that next piece that I needed, something about, not angle 4, but angle 3. If I take these two statements and substitute angle 2 and angle 1 into the second one, I get the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. And by the comparison property of equality, I can say the measure of angle 2 must be greater than the measure of angle 3. This is what they asked me to conclude. I have done that and have provided evidence. All right, so the second thing that we're going to look at is really something that comes into play a lot on standardized tests. And this theorem 510 says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. All right, if XZ is the bigger side of this triangle, or the big S. Now they're just comparing XZ to XY. Then I know that the angle across from XZ must be bigger than the angle across from XY. And that's what this theorem says. What this theorem allows us to do is now be able to organize angles of a triangle in order from least to greatest. That might ring a bell to some of you guys. So if I look at this right here, I know that 175 is the longest side. Therefore, the angle directly across from it, hopefully you can see my cursor here, has to be the biggest angle. I see 105 is the shortest side. So the angle across from it has to be the smallest angle. The question that they ask here is which two streets create the largest angle? So the largest angle would be opposite the largest side. So I know it's the intersection of MLK Boulevard and Valley Road. Okay. Now, Theorem 511 is essentially the converse. It's saying if the angles are not equal, then the biggest side lies opposite the biggest angle. The smallest side, or shortest side, lies opposite the smallest angle. All right? And I threw this proof in here. Remember, this is an indirect proof, so it's a little bit harder to follow because we assume temporarily that our conclusion is false. If that proof doesn't make sense to you, don't worry about it. I just put it in there to show you guys. Okay? But take a look at this. It says, in the figure at the right, the measure of angle S is 24. I'm going to put that in there. It says the measure of angle O is 130. I'm going to put that in there. And then it says, which side of the triangle is the shortest, and explain your reasoning. Okay? So, before I try to figure this out, the first thing that I'm going to do is figure out how big is angle X. All right? So how big is angle X? I know that in a triangle there's 180 degrees. If I subtract 24 and I subtract 130, that tells me that angle X is 26. Now, I know that opposite the smallest angle will be the smallest side. So I'm able to conclude here that OX is the shortest. And the reason is because, segment OX, sorry, is the shortest. The reason is because it's opposite the smallest angle. Okay, hopefully it's been a pretty easy lesson so far. Let's see how this is going to finish up for us. All right, this leads us to something called the triangle inequality theorem. This triangle inequality theorem determines whether a triangle can exist or not based off of the measurements of sides. All right, now the easiest way to figure this out is look at the triangle, find the two shortest sides. So in this triangle will be X, Y, and YZ. If those two sides added together are bigger than the third side, the triangle exists. That's all the triangle inequality theorem tells us, whether a triangle exists or not. So if I were to look at the example up above, and I look at 3 and 3, is 3 plus 3 bigger than 5? Yes, this triangle does exist. When I write down the 5 and I start folding these 3 centimeter sides in, they're going to connect. But now look at this one. The shortest sides, if they give me those 3, 2, 2, and 6, if I start folding that 2 centimeter side in and that 2 centimeter side in to try to get them to hook up or link right there, they're not going to be long enough to reach. So this fails the triangle inequality theorem. 2 plus 2 is not greater than 6. Okay, so let's take a look at a problem here. Are these 3 sides the potential measures of lengths of a triangle? So I'm going to identify the 2 smallest ones, 3 and 7. And then I think of the inequality, is 3 plus 7 greater than 8? If it is, then yes, this triangle exists. This work that I showed is my explanation. So let's look at the next one. The next one, the 2 smaller sides are 5 and 10. Triangle inequality theorem says the smaller sides added together must be bigger than the third side. Is 5 plus 10 greater than 15? No. So that greater than becomes not greater than, and therefore I can conclude, no, this triangle does not exist with those measurements. Okay? If I take this a step further, all right, and they only give me 2 sides of the triangle, All right, I have to think of the possible scenarios that could exist. So one scenario would be the triangle has measures of 4, 7, and something bigger than 4 and 7. The other scenario would be it could be something 4 and 7 is the biggest. So I'm going to look at these two scenarios and create an inequality from them. We're assuming in the first one that those two are the smallest sides. So I know that 4 plus 7 has to be greater than x, which tells us 11 is greater than x. And if I rewrite this inequality, it says x has to be less than 11. Okay? I look at the other scenario. I'm assuming x and 4 are the smaller sides. So when I do the arithmetic here, I have the triangle inequality theorem tells me x plus 4 must be greater than 7. Or it says x must be greater than 3. So now I have to look at these two inequalities and merge them together into a range for the possible third side. Start with the smaller number. We're going to write 3 less than x less than the bigger side, 11. And this is my final answer. All right? Now, if you paid attention, there's actually a shortcut here. If you look at the two given sides, 4 and 7. If I subtract them, or take the absolute value of the subtraction, that gives me what is known as the lower bound. And if I add them, that gives me the upper bound. So that's a little shortcut for anybody that paid attention through the whole video. Hope this helps. Good luck.